Well, all right, let's get started. So, Madam President, fellow Toastmasters, my speech is entitled Quantum Physics and Relativity, and my goal is in 7 minutes or less to introduce to you the two greatest scientific achievements of the 20th century, quantum physics and relativity. Piece of cake, right? Right. So these topics are very complicated, I get it. But my hope is by using certain ideas and certain concepts and to bring you guys along that I can make this topic a little bit more accessible and that I'm hoping some of you may even like the topics as much as I do by the end of this presentation. So, are you guys ready to get started? Great. All right, so what I want to do right now is introduce to you the two concepts that I'm going to use to help this process along. First, while most people think that science is the stuff that they had to do to get through high school, I'm going to use a slightly different definition right now. I want to call it science is basically just curiosity combined with tools. And I'll contend that curiosity has been there throughout time, but tools have evolved. And basically science is the evolution of tools to satisfy scientists' curiosity. And so the second concept I want to use is that the evolution of science is just better tools, and that we can understand 20th century science by understanding the evolution of tools along the way. So I'm going to give it a shot. Let's see if I can do it. Let's start with the evolution of science. And I have to go through this incredibly quickly to get through this in 7 minutes. So you start with antiquity. And to answer the question, why does the sun rise? The answer was the gods. Not very satisfying. But the tools weren't really that great, so that's the only answer you can have. You fast forward about 1,000 years, and you have a Muslim scholar who's curious about why the sun hurts when you look at it. So he develops a lens, he does some experiments, and he learns that light actually enters the eye, as opposed to what people thought at the time, the eye emits light in order to see. Fantastic discovery. Fast forward about 600 years, and Galileo is curious about whether the sun revolves around the earth or the earth revolves around the sun. So he takes that lens and he makes a telescope. And for the first time, Galileo confirms that the earth revolves around the sun. Absolutely mind-blowing for 1600. You know, I'll be honest, it gives me the chills just thinking about it right now. Go forward only 70 more years, and Newton is curious about why people don't fall off the bottom of the earth. If there's people on top, and if there's people on bottom, why aren't these people falling off? He takes Galileo's telescope, makes it a little bit better, and discovers gravity. And not only that, he discovers all the laws that govern motion and the bodies around us. And he writes it down in one book. And because of this, Newton is considered a god in his time in terms of science. But Newton is smart. And he says, listen, curiosity and tools is what got us to this point. So curiosity is going to continue to be there, and tools are going to continue to evolve. You know, if you think about it, Newton's sitting there saying, hey, the fastest thing I can measure is a bullet. The smallest thing I can see is a plant cell. So, I mean, you got to think that as things evolve, given how fast we've evolved in the last 1,700 years, you got to think things are going to get better. Great. So with that, with the evolution of tools idea, let's talk about quantum physics. It's just an evolution of curiosity and tools. Okay, so quantum physics, the soundbite, if you want to tell your friends, it's the study of things that are really, really small. But let's use that framework of curiosity and tools. The curiosity was when you take an iron and you heat it up, it turns red. When you heat it up more, it turns yellow. When you heat it up more, it turns blue. But according to Newton, it should just glow redder and hotter, and people were curious as to why. So around the late 1800s, they built this device called the cathode ray tube, and for the first time, it allowed them to see what's going on smaller than an iron atom, a subatomic particle, an electron. It's the first time they saw an electron. And what they realized is that electrons travel in little packets. Different sized packets, different colors. And that explained the iron for the first time. But they could only do that once they saw below the size of an iron atom. Nothing Newton could have ever measured in his time. In summary, quantum physics was the ability to study and see what goes on with really, really small things. Pretty amazing. Now let's move to relativity. And the idea is, again, the soundbite is being able to understand the science of things that go really, really fast. And the idea is, at the time, around the 1900s, people believed or knew that in order for sound to propagate, you need air. You need a medium. You need something for the sound waves to go through. If you think about water waves don't wave without water. And so people were curious. Does light, which is also a wave, does it need something to go through? Does it need a medium? And so they built this tool called an interferometer, which basically measures how light goes through things at different speeds. And what they realized is that light is very special. Light doesn't need a medium. It's the only thing we knew of, or we still know of at the time, that doesn't need a medium to propagate. Not only that, they realized that things that go really, really fast behave very differently than things that go the speed of a bullet. And so this was just an extension onto what Newton said. So they realized that they needed a whole group of science, not just for light, but for things that travel close to the speed of light, or really, really fast. Last thing before I close and let somebody else get up here. This intends to summarize everything that I've talked about. So if you think about what Newton had, it's the blue box. Everything he knew was slower than a speeding bullet and larger than a plant cell. But if you go to the right, you go to the yellow box. As things speed up, you need relativity. And if you go really small, you need special math as well, special science, quantum mechanics or quantum physics. And that's the brown box or the beige box. And so this represents, those two boxes represent extensions for what Newton gave us. And one final thought before I'm done. Curiosity is what brought us to this point, and the evolution of tools is what helped us understand all this. So with curiosity continuing to be there, and with tools evolving, you have to imagine something awesome is going to happen in the 21st century. I don't know what it is, but maybe I'll come up here in 100 years and I'll give you that lecture. Thank you.